Okay guys, we are going to be looking at the end of this unit, chapter 4. We're looking at how can you solve exponentials and logs using a graphing calculator. Now before we jump into that, let's go ahead and let's review this by hand. So looking at the first example, how would we solve this by hand? Hopefully you're noticing the 10 to the x is in each term. So we would set this equal to 0, x squared times 10 to the x, minus x times 10 to the x, minus 2 times 10 to the x is equal to 0. And then we can go ahead and factor that out. And we bring out 10 to the x, and we have x squared minus x minus 2 equals 0. And then we see that this quadratic is factorable, so we go ahead and factor that down, giving us x minus 2, x plus 1 equals 0, and then set each factor equal to 0 and solve. So we have 10 to the x equals 0, x equals 2, and x equals negative 1. And if I look at 10 to the x, I see that that cannot equal 0, because as x becomes more and more negative, this just becomes a smaller valued fraction. For example, like 1 over 10 to the 5th, 1 over 10 to the 6th, 1 over 10 to the 7th. So that we can throw away, so that does not give us a solution. But x does equal 2 and x equals negative 1. Okay, looking at the next one. This is e raised to the 2x. We looked at this one in the critical thinking, and many people thought of letting you replace e to the x. So then, and the reason we can do that, because if you think about e to the x squared, because of the rule when you raise an exponent to the exponent you multiply, we can see that that does work out. So then we'll replace that e to the x with a u. So we have u squared minus u minus 6 equals 0. And then we can go ahead and factor that down. So that gives you u minus 3, u plus 2 equals 0. Set them each equal to 0 and solve. And we have u equals 3, u equals negative 2. And then I can go ahead and replace e to the x back in, giving me e to the x equals 3 and e to the x equals negative 2. Now looking at how to solve for x, hopefully by this point in the chapter you're saying, oh, if x is in the exponent, we have to use logs to solve. And you are correct. We would take a natural log of both sides, use the power property on this, and this really becomes x times natural log of e, which we know natural log of e is 1, equals natural log of 3. So x equals natural log of 3 is one solution. Looking at this component here, I can think of it even in the way I looked at the last problem. As x becomes more negative, this becomes a smaller valued fraction. So there's nothing I can do here to equal this to negative 2, so that also does not give us a solution. Even if you tried taking a natural log of both sides, you cannot take a natural log of a negative. So either way you wanted to look at solving that, that will not provide you a solution. Okay, time to pull out the calculator. Let's see, how do we solve these on the calculator? One of the ways that we looked at solving an equation on the calculator is by looking for the point of intersection. So if we plug this log base 10 of x in for y1 on our calculator, and don't do it yet, let's write the notes of what to think about and then we'll pull out the calculator. And I plug in this one in for y2. Remember the series of commands to press on your calculator. We're going to be pressing second, trace, I believe it's option 5, is intersect. And we are going to, well, first of all, we have to see, well, how many solutions are we going to get? And this is why it's actually important that you think of the sketch of these two graphs first, so we know how many solutions we're looking for. So if I think about y1, what that graph should look like, that's a log, a basic log graph. If we think of log base 10 of x, we know the point 1, 0 will exist because log of 1 is always 0. And we go ahead and we know the shape of that log. And then if I think about x squared minus 2, that's a quadratic. That's been shifted down 2 units. So we know its general sketch is going to look like this. So we know that we're going to have 2 solutions, one here and one here. These are where our solutions lie. And remember, we're looking for the x values because we're looking for where are the x's equal in these 2 functions. So we know we're going to have x equal to something less than 1 and x equaling something greater than 1. Now you're going to notice in a moment, and I'm sorry I can't show you my calculator on this screen, but you're going to notice in a moment that it's actually imperative that you knew that sketch, because your calculator doesn't show you this part of the log graph. Just because the logs get so close to 0, your calculator doesn't have enough pixels to show you that. So let's just make a note that it's important to sketch. So you will compare your sketch to the calculator, and that it's important to know the basic parent functions to determine how many solutions you will have. Determine how many solutions you will have. And so now we can just take out the calculator, and we know that we're going to plug these 2 pieces in, and we're pressing second trace intersect, and we're going to have to do that twice because I'm going to see where's the intersect between this curve and this curve here, and then I'll have to redo that for this curve and this curve. Now notice when you do this on your calculator, it will say first curve question mark, second curve question mark. You need to make sure that you're in the region that you want to find your point before you guess. So if you do this correctly, you should have x to equal about 0.01 and x to equal 1.472. All right, let's take a look at this next one. Why don't you try this one on your own and then just check your work with me at the screen. Again, make sure that you put 1 in for y1 and another one in for y2. And I'm just thinking through this. If I think of a basic sketch of e to the x minus 2, it is going to be a quadratic. And then if I think of a basic sketch of x cubed minus x, that is going to be a cubic shape. And I know that the end behavior is going to go down and up. So down, up, and it should look something like this. So now I go to my calculator and I press it, and I should have 2 solutions. X is equal to negative 0.886 and x is equal to 0.706. All right, last but not least, we take a look at how do you solve inequalities on the calculator. These are those less than or greater than pieces. Now before we begin, you do have to remind yourself that on a graph, a function is less than another function when it is below that function. Because when you're looking at an actual function, you're basically looking at the y values. You're looking at the outputs, and you're saying, hey, where is the outputs of one function less than the outputs of another? And so you're looking for visually, where is it below, because the y-axis is vertical. Okay, so if we use the previous problem that we just looked at, e to the x squared minus 2, x cubed minus x, we know that our basic shape, this was our y1, e to the x squared minus 2 was a quadratic, and it looked like this. And then x cubed minus x was a cubic that looked like this. And if I'm looking for basically we're looking for where is the blue graph below the magenta graph. So where is the blue graph below we'll go ahead and call this purple, even though it's magenta, I think, below the purple graph. So if I'm looking at that, I can see where these pieces are. The blue graph is below the purple graph here, everywhere here, about. We know that we are going to have an interval notation answer because there's many places that it's below. And again, we're looking here for what x values show the y values below the other graph. And if I look at this x value, when we look at where these two intersect, now on our calculator we're going to be pressing second trace, option number 5, and we're going to find that this is going to intersect at 0.886 and this will intersect at 0.706. Now, where are they less than? They're equal to at these 2 points. Oh, I don't know the y values, but that's the x value. There's some y value. I obviously don't have my calculator on me. But where is the graph less than? It would be in the area of, oops, not a bracket, excuse me, parentheses, 0.886. Wait, is it a less than or equal to or a less than? Oh, excuse me, less than or equal to. So it would be a bracket, 0.886 to 0.706. Okay, now if we think about it in that case then, extending our thinking, where is this function greater than the cubic? Now we're looking for where is it above. We're looking for where is the blue graph above the purple graph. And if I think about this sketch again, now it's going to be everywhere here, and actually this one's, you want to think about which one has a greater y value. So obviously they're both increasing here, but if I look at like the x value of like right here, which one currently is greater at this x value? Well, at this x value here, it's less than. If I think about this x value, then the y value would be here. So the blue graph is actually greater than the pink graph. If I think about this x value, the blue graph has a greater y value than the magenta, or than the purple. So if we think about that here, actually, where's the blue graph above the, oh, I think did I draw this sketch wrong? The answer should be from negative infinity to negative 0.886, and from 0.706, oops, excuse me, to infinity. And that's because you can see, yeah, exactly as we were thinking about, the purple graph is less than the blue graph here. So it's everything above there. Okay, lastly, and I'm sorry guys, I don't have a calculator to show you, but hopefully with these notes you'll be able to do that, and we'll obviously look at this again tomorrow. When you're looking at an inequality like this, here you're asking yourself, when is the log graph between the y values of 2 and 3? So let's go ahead and let's write that, and then we'll look at it on our calculator. When is log base 3 of x between y equals 2 and y equals 3. So if I'm thinking about just a general sketch of this, and I hope you guys can see this, but if I think about just a general sketch, a log, I'm going to have to do this on the second page. A log base 3 of x is going to have the point 1, 0. And if I think about when x is 3, 1, 2, 3, log base 3 of 3 is 1. So we know that my graph's going to look like this. So we will need to adjust our window because I'm looking for where is this graph in between the values, the y values of 2 and 3. So this value is 1, 3, 1, 2, 3. So it's going to be somewhere way over here. So if I adjust my, and if you think about like log base 3 of what number would equal 3, well that would have to be 27. Log base 3 of 27 equals 3. So I know that I'm going to need to be looking at the x values. X minimum, you could start at 0, but x maximum, we want to have things looking at about 30. And then if I'm looking for where is it in between then, I'm going to set y1 equal to log base 3 of x. I'll set y2 equal to 2 and y3 equal to 3. So on your calculator, it's going to look like, wait, sorry, that's what x, I drew that piece in as 1. I'm looking for where is the function going to be in between 2. So on your calculator, you're going to have a horizontal line of 2 and a horizontal line of 3. And you'll see the graph in between in these two values. So what values is it in between those two values? You'll see the answer being between 9 and 27. Okay, that's it.